Hello everyone and welcome to my YouTube channel. In this video, we're going to be looking at a few questions, okay? Algebra related question. In the first question, we're going to be solving for x, okay? And I'm going to be showing you a method that you can utilize to solve such questions. The second question, we're going to be using the quadratic formula, okay, to find our solution. And then lastly, we're going to be finding values of k such that our equation would not have real solutions, okay, for that value of k. So we're gonna be starting off with question one. So now in the first question, let's see. So we've got x squared minus 4x minus 5. Okay. And that is equal to 0. Now we want to find factors for this equation, right? So there's a simple method that you can utilize. Okay, all you need are the constants from the equation. So we're going to plug in two values here, right? One value comes from the coefficient in front of x squared, and the other value comes from the constant that has no x attached to it. Okay, so we're going to have a, which comes from here, okay, and then the other value is c, which is this one. So we're just going to put these values on top here, 1 and 5. So now in the next step, all you have to do is break it down, right, into its factors. Factors of 1 are 1 and 1. Factors of 5 are 5 and 1. So now in the next step, we want to take this, right, negative 4. We're going to put that coefficient value here, okay? So now this is going to help us with assigning positive and negative signs. So now the next step here, we cross multiply. So we'll get a 1 there, and 1 times 5 gives us 5. So now we're going to be adding these two numbers, right? But we need to have a sign associated. So we're going to assign a negative to the 5 and a positive to the 1. So we add up these two, you get negative 4, okay? Minus 5 plus 1. So now once you get those signs, you can just transpose them here. So I'm just going to write this neatly. And I'm going to exclude x. So x minus 5 is one factor, and x plus 1 is the other. So now what you need to note is that you see these values here, right? This one here, the 1 and 1. Okay, those are just coefficients. But when you're writing down the factors, the x is always going to be there. So this 1 and 1 was 2 and 2, or 2 and 3. Then we'd have 2x and 3x. So I just wanted to point that out so that you're aware. So now we can proceed here. I can just simplify this now. Okay, we've got our factors. So x minus 5 and x plus 1. And we equate that to 0. So now we have x minus 5 equals 0, or x plus 1 equals 0. So now from here you can just write down the final solution. So x is equal to 5, or x is equal to minus 1. So now you can test these values out to confirm that the solution is correct. So I'll leave it up to you. So now if we look at our list of options here, the correct option would be C. Okay then, so now let's go on to the second question. So now in question 2, we'll be employing a different method, okay? So first, let's write down the equation. So we've got x squared minus 6x plus 2 is equal to 0. So now, let's first define what our quadratic formula is. So x is equal to minus b plus minus square root of b squared minus 4ac, and divide all of that by 2a. So now, as you can see, we are different constants, right? A, B, and C. So now we get those from the given quadratic equation. So now let us quickly define them here, right? So A is equal to 1, B is equal to minus 6, okay? And C is equal to 2. So apart all of these from the equation, right? So for this one, A is equal to 1, I got it from here. For B is equal to minus 6, we got it from there. And then lastly, C. So now, since we've gotten our constants, we can plug it in and then simplify it. So now let's see. So it's going to be minus 6 plus minus square root of minus 6 squared is 36 minus 8. Okay, so I'll just simplify that right to 8. Okay, and then all of this we divide by 2. So now each of these terms above will divide by 2. Okay, so we're going to have, it's going to be 6 over 2 plus minus. So this can be broken up into, you see the 28. Okay, that can be broken up into 7 times 4. So now that's 7 times 4. We simplify it. It's going to be 2 root 7 over 2. So now the final answer here is 3 plus minus square root of 7. So 2 goes into 6 3 times, and then 2 cancels that. So now if we look at our question here, which of these would be the correct one? It would be E. So now, at least we have a better understanding. There are two ways of doing this, right? Depending on the use case. In this case here, we needed to use a quadratic formula because there wouldn't be another way of doing it. Okay. So let us continue to the last one. The last question, let's see. In question 3, we have the following, right? Equation x squared minus 4x plus k is equal to 0. So now we want to find the values of k where this equation will have non-real roots. So the way to do that is to use the discriminant, right? So it's defined as b squared minus 4ac. So for this particular case, okay, if the discriminant is less than 0, we can then conclude that we would have non-real solutions. Okay, so now we just want to find values of k, right? Not a particular value, just a range of values. So now we can do that, right? So now let's use this formula here and see. So this is going to be b squared. So we're going to refer to our equation. Okay, we've got b is negative 4, a is 1, and C would be a K. So now let's plug that in. So minus 4 squared is 16. Minus 4, 1 times 2. So now, if we simplify this, what do we get? We get, but let's quickly rectify something quick. Okay, so you see, C here, right? Has to be K, not 2. So put a K there. So now this would be 16 minus 4K. Okay, so now the formula that we've derived is in terms of K, which is good. So now we need to find the values of K, right? So previously, you remember we stated this here. We can utilize that here. Okay, so what are we saying here? This discriminant less than 0. Okay, so I have to take 16 minus 4K less than 0. We can actually get a range of values for K. Okay, so now to simplify this, this is going to be K greater than 4. So any values of K that are greater than 4, if you were to use that value, right, in this quadratic formula, then you wouldn't be able to find real solutions. However, if you plug in values of K that are less than or equal to 4, then your solution would be valid. So now that would be option A. And that is basically it. So we're going to resume with this in a part 2. So tune in next time.